So in this demo, we'll walk through an example of the whole recipe that we just mentioned at the end of the previous video. So this notebook, it comes originally from Professor Joseph Gonzalez from the spring of 2020, but I've made some changes and adapted it for this semester. So this demo will be two parts. The first part will look at the just do train test split, and just build a basic linear model, and then we'll work through some cross validation in the next section. Um, Great. So let's go ahead and do our main imports, NumPy and Pandas. We'll also use Plotly in this lecture, in this demo. And we'll be using sklearn to build our linear models. So the data set that we'll be working with in this notebook is the miles per gallon data set, which comes as a default data set from Seaborn. I think it's also a default data set in R, so you may have seen it there too. But anyway, this data set, it has for a bunch of cars, it has their miles per gallon, along with a bunch of other features. So we can take a look and we can say, yes, we have MPG, but we also have data like the number of cylinders in that car's engine, the engine's horsepower, how much the car weighs, its model year, and then some text data, such as where it comes from or even the name of the car. The next thing we'll do is we'll drop any rows that have missing data. So there's unfortunately a few cars in here that have missing values for horsepower. So we'll just get rid of those. There's only like 5 or 6. Of course, this isn't necessarily the smartest strategy. Maybe there's something interesting about those cars that we should hold on to, but it's the easiest thing to do. So we'll do it just for this video. So the first thing we do, remember the first step in that recipe is to do a train test split. So here's a little bit of an example as to why. And there's a number of ways you can do this train test split. There's 3 ways that I'm going to highlight in this video. The first way is to just use pandas directly. So what you can do is you can just call .sample on the data frame. So we've named our data frame data, and we can just call .sample on that data frame. And then what this will do is that if we set fraction equal to 1, what this will do is it will just shuffle the data. So you can see the rows have flipped from before. Before, the first car was the Chevy Malibu from 1970. Now it's some other car, this French car from 1972. So that's that. So the first we do is we shuffle the data. Note that I set the random state here so that we get the same shuffle, we get the same result every time. This is good for reproducibility purposes, but in general, you might not want to set this. But I'm just setting it here. And then what we do is now that we have the shuffled data, we'll take the first 90% of it for our training data and the remaining 10% for the test data. So I need to figure out first where I'm going to split. So the first 352 rows are going to be training data, and the other 40 rows, I guess, are going to be test data. So I can do that as I can just shuffle data.iloc. I can just select the first 352 rows and then the remaining data. This is just basic pandas notation. And we can see again the lengths of our TER, our training data, and our T, our test data. And then we can look at them. Cool, cool, cool. Maybe we shouldn't be looking at the test data, but just to assure ourselves that we did the train test split correctly. And then to make sure that no data disappeared, we can just do the sanity check for us here. Another thing you can do is very similar. You can just use NumPy instead. So what we can do is we can set a random seed and we can call this function np.random permutation on a range that has the same length as the length of our data. So let's just look at what this looks like. So what this is saying is this is just taking all the numbers from 0 to 393 or whatever it is, 0 to 392, whatever the number is, and then shuffling them. So then now we can use this array. We can do the same thing that we did before, and then just pass that, do the same iloc thing to shuffle our data. And then here you see I'm using the same split point syntax that we did before. So I actually prefer this way. It doesn't really make any difference whether you use directly pandas or NumPy, but I've just found that I've just naturally leaned towards using NumPy for whatever reason. But as you might expect, the fancy, wonderful sklearn has this functionality for us. So there's a function from the model selection module in sklearn, and it will just do this entire process for us. So we can just literally call train test split on our data. We tell it how much data we want to set aside for test, in this case 10%, so 0.1. Again, we set the random state for reproducibility purposes, and then it'll just do it for us. And you can see the data here. So it's just 3 different ways to do a train test split. Which way do you use? Which way should you use? I don't care. I don't think it makes that much of a difference. The first thing we can do is we can just build a basic linear model. The first model we're going to do is we're just going to look at all these quantitative features that are available to us. So we have 6, I think. We have cylinders, displacement, horsepower, weight, acceleration, and model year. And we can write a function that will just create the design matrix for us. We give it some data frame, either the training data or the testing data, and it will return these 6 columns. This looks very similar to what you saw in lecture 14 with feature engineering. We have our data, our whole data, and then we're transforming that into a design matrix that we want. So we can go ahead and do that. Now what we can do is we can fit a linear regression, where we can make a linear regression object, and then fit this, we fit the model basically. So we have here a basic design matrix of our training data, and then we have our y, which is our miles per gallon. So again, this is x, and this is y, and we can fit the model. We're just doing basic, pure linear regression here, nothing fancy. And it fits, okay, good. To kind of help us evaluate our model, we'll just define this RMSE function. Not super interesting, you've seen this before. And then we can see the training error. So what we do to calculate the training error is we predict on the data on which it was fit. So again, here's x, and we predict based on that to get y hat, and then we compare y and y hat, and we see the training error is about 3.37. Something else we can do, but you never actually should do, I'm just doing it just to show you, is we can also look at the test error. And you can see the test error is 3.68, 3.69. So you can see that this test error is higher than the training error. And again, that's to be expected because the test data is new data. But of course, you should never actually look at this test data until you're done. You're fine. You finalized your model. You've committed. You've done everything you needed to do. You should never actually look at this test error. So let's actually just go ahead and delete these cells. So just to pretend that we never saw it. So that's the end of this first half of the demo. And in the next half, we'll do some cross-validation.